Hello everyone, welcome back. Hello and welcome back to PA Academy. So this is example one on that video series, mesh analysis. So in the previous part, it was more like an introduction into mesh analysis, where I talked about what mesh analysis is all about and how to go about to solving them. So now this example, we are going to be using real numbers. You can see we have a circuit here, unlike the other ones where we are using more like alphabets. So now let's get started. Now before I continue, if you missed the previous part of this video, that's the introduction part of mesh analysis, please check the description of this particular video. You'll find the link to that video. Alright, so right here now we already have this circuit and we are asked to do what? He said find the current in each mesh and the current passing through each resistor in the circuit. So that means in this particular mesh, you have to find the current that is flowing here and the current in this particular mesh and the current in each of this resistor. So let's go about it. So like I said, first thing you should do is to identify how many mesh are we having in the circuit. So if you're familiar with what mesh is all about, which I've explained in another separate video, this here is a mesh. Okay, this, before I even show you the current direction, so let me call these points A, B, C, D, E and F. So A, B, E, F and back to A is one mesh. B, C, D, E and back to B is another mesh. So we are having two meshes in this particular circuit. So having identified that, the next thing is to do is to pick our current direction. So I'm going to pick a clockwise direction. So for this particular mesh, let me call it I1, and then for this also a clockwise direction for our current, I'll call it I2. So let me call this mesh 1, and let me call this mesh 2. So now that I've picked the direction of current, now let's add our polarity. So for the voltage source is constant, this is going to be plus, minus, and this is going to be plus and minus. So the longer side is positive, the shorter one is negative. Now for the resistor, which is the element we are having, for us to add the polarity, so from this mesh 1, this is going to be plus and then minus. So this is going to be plus and minus in this direction. I hope by now you should be familiar with this. I've explained it when I was talking about Kirchhoff Voltage Law and in the previous video. So also for the mesh 2 now, this is going to be plus and minus, and then for the 1 ohm resistor we are going to be having plus and minus. So now the next thing for us is to pick each of the mesh and then simplify it using Kirchhoff Voltage Law. So solution. So now for the mesh 1, and that mesh 1 is that is A, B, E, F and back to A. So that is the mesh 1. So now we are starting from point A. So this is the first element you are coming across. So from positive to negative, so that's going to be minus 4 times I1. That will be 4I1. Then you should continue like that in this direction now. So this is the next one. Now from plus to minus, and then we're having a 2 ohm resistor, and then the current here is I1. So that is going to be minus 2I1. Also for this 2 ohm resistor, we also have another current that is passing through it, which is I2. But we are going to be looking at it in this direction, the direction for mesh 1, for the current in mesh 1. And that's going to be minus to plus. That will be plus 2 because of I2, 2I2. I hope you get. So when you're having an element that is between two mesh, so this is how you go about it. So once we are done here, we come to E, to F. There's no element here. And then from F to A, we are having a voltage source, which is from negative to positive. That is going to be plus 28 equals to 0. So now let's simplify what we are having here. We are having minus 4I1 minus 2I1. So that will give us minus 6I1, then plus 2I2, then equals, so this 28, let's bring it to the other side of the equation. That is equals to minus 28. And what we are having here is our equation 1. We take note of that. So now let's go to our mesh 2. So for mesh 2, this is mesh 2 now. The parts for mesh 2 is that's B, C, D, E and back to P. So that's for mesh 2. So now if you are starting from B, straight like this, so from positive to negative, and this is 1 ohm resistor, and then the current there is I2. So that is going to be minus 1 I2, so you can just write it as minus I2. If you have 1 here, you can try to write your 1, but it's still the same thing writing it like this. So from C to D, this is plus and this is minus. So that will be minus 7. Remember, you are not going to multiply the 7 with your I2 because this is a voltage already. It's already in voltage. I hope that is clear. I didn't mention it here, but I've mentioned it in the previous video. This now, we cannot multiply it with I1 because it's already in volts. But all these values, like the one I'm having here, this is, remember V is equals to IR. This is I2, and our R here is 1. So that's why we can multiply them. We can multiply 4 multiplied by I1 here. That's because we are getting the volt, we are calculating the voltage. But since we already have voltage value here, there's no need to multiply it with I. So that's why this one is ordinary 7 volts, but you can just indicate it as 7. So now from D to E, there's nothing here. Now from E to F, so from positive to negative 2 ohm resistor, the current flowing it is I2. That will be minus 2I2. Also, here we also have another current which is I1 flowing through it, plus flowing through it in this direction. But since we are looking at mesh 2, that is from minus to plus. That will be plus 2 because of the current I1 rather, 2I1, and then back to B. So there's no other element, then that will be equals to 0. Alright, so now let's simplify this. So if you are to simplify this, we are having minus I2 and minus 2I2. That will be minus 3I2 plus 2I1 equals to. So if this 7 comes to the other side of the equals to, we are going to be having equals to 7. And what we are having right there is our equation 2. So now if we solve equation 1 and equation 2 simultaneously, so solving equation 1 and equation 2 simultaneously, we are going to be having our I1 will give us. Alright, so now that we've gotten the current that is flowing through each mesh 1 as mesh 2, we've gotten to be I1 is 5 amperes. That's the mesh 1. Current flowing through this mesh is 5 amperes, and current flowing through this mesh 2 is 1 ampere. So now let's go ahead and calculate the current that is flowing through each of these resistors. So we have the 4 ohm, 1 ohm, and then 2 ohm resistor. So to calculate the current that is flowing through each of them, so let's start with the 4 ohm resistor. So that means we are going to be having current through the 4 ohm resistor. So if you look at this 4 ohm resistor from this mesh, you can see that the only current that is flowing through it is the I1. This is the only current that is flowing through it, and the value for our I1 is 5 amperes. So that means the current that is flowing through the 4 ohm resistor is I1, and that is 4 amperes. So it's equals to I1, and that is I1, and that is 5 amperes rather. 5 amperes. So that means the current that is flowing through the 4 ohm resistor is 5 amperes. Now, whenever you give the value of the current, always indicates the direction. And now, this is going to be the direction. Now, the direction that we assume to be clockwise, that means it is correct. So you can see, in clockwise direction, the current is what? Is 5 amperes. The reason why it's correct is that we are getting a positive value for the value of the current that is flowing through the 4 ohm resistor. When we get to the next example or subsequent examples, you understand what I'm saying. So now let's look at the current that is flowing through the 1 ohm resistor. The current that is flowing through the 1 ohm resistor. Also, if you look at it here, the only current that is flowing through the 1 ohm resistor is I2. And we've gotten our I2 to be 1 amperes. So the current flowing through the 1 ohm resistor is I2, and that is what? 1 amperes. That is 1 amperes. So also the direction that we've taken in this direction like this. So that means the direction that we assume is correct because we are having the value of our current to be positive. So that means it's correct. That means the current is actually flowing in a clockwise direction. Alright, so now let's look at for the third one, which is the current that is flowing through the 2 ohm resistor. Now if you look at this 2 ohm resistor, there are two current that is flowing through it. We have I1 flowing through it and we have I2 flowing through it. Now in the part 1 of this video, I said when a resistor or an element is sharing is between two mesh, or maybe we have more than one current flowing through a particular element, for you to get the exact current that is flowing through that element is two things. We can either have it as I1 minus I2 or I2 minus I1. Now what will determine if it is going to be this or this is you consider which of the value is higher. If I1 is higher than I2, you use this to get it. If I2 is higher than I1, then you are going to apply this. So now let's look at this closely. So from the value of I1 and I2, we have seen that I1 is higher than I2. So that means we are going to be applying this. So you are going to be applying I1 minus I2. And in doing that, we are going to be having 5 amperes minus 1 amperes, and that will give us 4 amperes. So that means the current that is flowing through these 2 ohm resistor is what? Is 4 amperes. Now for us to determine the direction now, the direction is going to be the one that is coming first, which is one that is more higher. So that means if you look at it, 1 ohm, so when it gets here, it is coming down like this. So that means the direction for this is going to be like this. It's going to be facing downward. So always indicate the direction whenever you are giving the values of the current that is flowing through each of these elements. Alright, so that is it for this video under mesh analysis. I hope you find value in it. If you do, please give this video a thumbs up, and if you are yet to subscribe, please subscribe. So in the next part of this video, which is example 2, we are going to be looking at another example. Remember I said we are going to be looking like 5 different examples, and I believe at the end of those 5 examples you'll be good to go with mesh analysis. So if you also want to have more idea about how to about what Kirchhoff Voltage Law is all about, I've done a separate video about it. If you have not watched it, I'll leave a link to it in the description of this particular video. And also if you want to know what the difference between a mesh, a loop, node, branches, because I'll be using some of these terms as we progress under mesh analysis and other kind of analysis. So if you want to know more about and the difference between those terms, I've done a video about it. Check the description of this video, you'll find a link to that particular video. Alright, so thank you very much, and I'll see you all in example 2.